Number 12, another titration. If we read through this, it's asking how many grams, that's our unknown, of lead nitrate. So we're going to solve for grams, not volume. But what information are we given? We're told that we have a volume and molarity of potassium iodide. So let's write our reaction. Potassium iodide reacts with lead nitrate to form lead or potassium nitrate and lead iodide. So we'll need 2 of each of those. So starting with what we know, 0.0750 liters divided by 200 moles in 1 liter. Our ratio of potassium iodide to lead nitrate is 1 mole of lead nitrate to 2 moles of potassium iodide. And we're solving for grams, so we just need to know the molar mass of lead iodide, or lead nitrate. PB NO3 2 331.21. Okay, part B, how many grams of precipitate would you produce if you started with this amount? So this is our given. Now we have to figure out what's going to precipitate. All right, so looking back at our equation, obviously these are solutions, but we're going to have one product is potassium nitrate, the other is lead iodide. If we check our solubility table, we'll see that lead iodide is what will precipitate. So that's what we're going to be solving for. And it wants grams, and I'm going to write in here lead iodide. So I start with what is known. I know that I have 75 milliliters. I didn't need that. So that's 0.075 liters. And the molarity is 0.2 mole per liter. My ratio, we're going from Ki this time to lead iodide. 1 mole of lead iodide will react with 2 moles of Ki, and we want grams, so we need the molar mass of lead iodide this time, which is going to be fairly heavy, because iodine's heavy and lead's heavy. 461.01. And that is how you do 12. 13. We got a big old ugly equation, and we got to balance it. And I have 2 potassiums. I have 2 chromiums, so that's going to be a 2. I have 7 oxygens, so that has to be a 7, which makes 14 hydrogens. So this needs to be 14, which gives me 14 chlorines, and I have 3 times 2 is 6 chlorines, 7, 8 chlorines, and I have a 3 here, so that'd be 9, 10, 11. If I double that, that gives me 14 chlorines, and that is balanced. How many grams of iron would it take to completely react with 1029 grams of potassium chromate? So in this case, I'm starting with potassium chromate, and I'm solving for grams of iron. Potassium dichromate. Let me say the correct name. Potassium dichromate, 294.18. Did I say that right? Because I have already... 294.18. Look at that. I was able to remember that. Grams in 1 mole. I have 1 mole of potassium dichromate reacting, and I'm solving for grams of iron. So I'm going to make 2 moles of iron, or I'm going to use 2 moles of iron for every 1 mole of potassium dichromate. And then I have to change it back to grams. 55.85 grams divided by 1 mole. And that would be how to solve that. Next question gives us 52 grams of iron 3 chloride and wants us to go back and solve for potassium dichromate grams. 52 grams of FeCl3, molar mass of FeCl3, 162.2, I keep wrong button, 62.2 grams in 1 mole. And I'm going to go from iron chloride to potassium chromate. So 1 mole of potassium dichromate to 2 moles of iron 3 chloride, and the molar mass we already calculated for potassium dichromate. And that would be that. Letter C, how much potassium chloride? That is what we're solving for. And notice it's in moles. And we've got 95 grams of iron. 95 grams of Fe, the molar mass of iron. If I look here, I'm going to go from iron to potassium chloride. It's a 2-to-2 ratio. And that's where I stop because I'm only going to moles. Letter 10, no, letter 10. Letter D. We're solving for chromium 3 chloride, which is down here. That's unknown, so I should have done that in green, not yellow, sorry. And we're given volume and molarity of hydrochloric acid. So, to change to moles of hydrochloric acid, we need to know the volume. And we multiply that by the molarity. The ratio of hydrochloric acid to chromium 3 chloride is 2-to-14. 2 moles of CrCl3 to 14 moles of hydrochloric acid. And now for grams, just multiply by the molar mass. CrCl3, 158.35. And that would be how you work that guy.